Alrighty, guys, attention please. We're just about to kick off with the next workshop, and it looks like all of you have settled down. Yeah, we did notice we hadn't ordered enough pizzas this time, so we'll make sure we order more for next time, more drinks and more cups as well, so don't worry about that. Anyways, welcome to the Practical Software Engineering Workflow workshop today. My name's Ash, I'm the Vice President of Coders for Causes. I do want to quickly say congratulations to all of you for making it into the projects. You did make it past about 100 plus applicants, so that means we did see potential in you to make meaningful contributions to some of the causes we are supporting today. And also we see the potential in you to become 10x developers, assuming, like Celine said, that you commit to the project and you show up and make the most out of the experience, because I can guarantee it that by the end of this project period, companies will want to hire you and you're going to feel very confident when you enter the industry. Cool. So the goals of this workshop are pretty much what you're seeing in the contents over here. By the way, this website is, you can access it by going to workshops.codersforcauses.org if you want to follow along. So basically we'll be talking about how software engineers work in a industry workplace and why they follow some of the practices that they follow. We're going to be talking a bit about Git, GitHub, and code repositories, and then at the end we're going to be running an interactive workshop where we kind of simulate a real workplace and how we would collaborate in an actual workplace using Git. And then also provide some resources that you'll find helpful throughout this project. So let's kick it off. Yeah, so let's talk a bit about collaboration. Do you remember your first project that you did when you were at uni? How did you share your code with someone? How did you work in a team? Now, some people might have sent their code over MS Teams. Other people might have zipped it into a Google Drive and sent it to their friend. But suppose I was making a calculator app. How am I going to get one person to make the addition function and the other person to make the multiplication function? Does that one person code the addition function, copy the code, send it to the person, and then the next person starts working on it? It can get a bit juggly if you do it that way. But I've got this really cool video over here. I don't know if any of you have watched Silicon Valley, but it talks about another problem that can happen when you're trying to collaborate on a project. In this specific video, they are trying to build a startup and they've got 5 people working on it. They're just friends, they live in the same house, but they have no system whatsoever to work on the project. And you'll get to see some of the, well, one of the main problems that can also happen. Okay, yep. Awesome. Yep. We're gonna have a project, we're gonna get divided into 2 teams after that. Just let me know that you are late when we do that, because I'll be running a workshop for you guys. I'll mark you as present afterwards. Thank you. Awesome, so as you saw in the video, when they're trying to collaborate on a project, 2 of the dudes pick up the same task and think the other person's doing something else, so they end up doing the same work. That's the other problem that can happen when you're collaborating, that you don't know, you're not able to track the progress effectively and see who is doing what and what work is being done and what level it's up to. So that's where Scrum comes into play. So what Jared showed us at some point was a Scrum board, somewhere over here. So these typically are known as Kanban boards. So on GitHub, we have GitHub projects, which can let you make a table like this, and you can have columns with whatever names you want. Typically, you might have a to-do column or a backlog column where you create the tasks that meet some business value of the product you're trying to make. And then you have a ready column where you move the tasks once they're ready to be picked up by one of the developers. And then when one of the developers assigns themselves to it, it gets moved into the in progress section. After which, when they finish the task, they move it to the QA or the testing column. And now one of the testers from the team will pick up these issues. They will work on this and see if it meets the quality standards or not. If it doesn't, they'll move it back to the in progress column and reassign the developer that was working on it. But if it does meet the quality standard, they'll move it to the done column, and then that task is set to be done. Jira also provides Kanban boards. Here's one of them. So we do use GitHub. We may or may not be using Kanban boards, but we do have GitHub issues, which looks like this. It's basically a to-do list, and all of these are to-do items that we call issues. And you can see who's assigned to what issues over here. Yeah, when you click on the issue, you should be able to see some more details over there as well. So there's going to be a repository for each of the projects you're assigned to. There'll be one for Penny, there's one for Coexist. I don't think there's any one for the beginner projects because you guys have to make your own repositories on your own GitHub account. Cool, so that's Kanban boards and Scrum. This talks a bit about the agile way of working. So typically, when you're doing a project, you're going to have a sprint. You're going to have multiple sprints, and these sprints can be from like about 2 weeks to 4 weeks long. During each sprint, you have a Scrum session every day. That's basically this board. And before the sprint starts, there's a bit of sprint planning that happens, which is kind of like what we did when we were creating issues on GitHub for you guys to pick up. And we're going to be doing one big 4-week sprint pretty much. And after this sprint is over, we do a sprint review. Well, we do the retrospective part, which is like collecting feedback, finding out where we went wrong, what we did right, what we should keep doing, what we could do better, and just trying to improve our next sprint. So the next thing we want to look at is Git. Suppose you guys are working on a project. How would you code in the same code base? That's one of the other problems we talked about earlier. Like you wouldn't want to send someone your code and then one person has the source of truth and you're passing that to the next person, and then you have to keep track of who has the latest version of code on their MS Teams DN chat. But instead, you can use something called Git. Now, this is a video by Fireship. He explains it in 100 seconds, and I think he's going to do a better job than I can in 100 seconds. It was quite a bit to take in 100 seconds, but I don't know how much you captured. The summary is that Git is a version control system. So you can store the different changes of your code in a history. We call these changes commits. So if you make a change to your code that breaks the entire code base, you can actually go to a previous version. That's one of Git's superpowers. That's what it allows you to do. The other tool Git serves as is a tool for coordinating work for different changes, and it does this by allowing us to create branches. Now, Fireship uses a really nice analogy. I think he talks about it in terms of alternate universes. Can't remember where it was, but yeah, you can create he said you can create a different branch of your code. It kind of is like an alternate universe because a branch is a copy of a code from a certain point of time. But now you can make changes on this new branch and they will only remain on this new branch, not on this branch you branched off from. Better diagram down over here. This gray line is our main branch. So, let's just assume that time axis is this parallel to these lines, and time increases downwards. So this is my first commit on the main branch, and someone has just created another branch from this commit, represented by this blue line. Now, whenever they make this commit over here and this commit over here, those changes are not going to appear in this main branch over here. So my app might be using the code from this main branch. So even though this person has created new features, my app's not going to reflect those features on it because it's using this code base, so it only has these changes here. So even when I commit these changes here, my app will show those changes because it's in this branch, but these changes are not going to be on this blue branch over here. And at some point, somebody creates another branch from this blue branch, represented by this yellow branch, and they make a change over here. And this blue branch merges back into the main branch. Merging is how branches send their changes into this branch over here, into whatever branch they want to merge into. And same with the yellow one, it merges back in over here. So this commit here is going to have the changes from the yellow branch as well as the blue branch. So my app will see the features that were added in these 3 commits over here. Yeah, this is a kind of an overwhelming diagram, but don't get scared. This is just showing some of the typical branches that workplaces may have, projects at workplaces may have. Like you might have 2 feature branches. You might have a development branch, you might have a release branch, a hotfixes, and a master branch. Master branch is the branch, or it's also known as the production branch. So your app might be using the code from this branch. But whenever you want to add a new feature, you would create a feature branch and make changes in that, and then you would merge the feature branch into the development branch, and then you would merge the development branch to the release branch when it's ready to be released. You'd want to test it thoroughly to make sure it actually works before you actually release it and merge it back into main. This 1.0 just represents the version of the app. So yeah, this is kind of the workflow it follows. Different projects, different workplaces use different types of branching. I'm not going to go over those over here. But in CFC, we just have a different branch for a different issue, and we just do code reviews and merge them back into main. Cool. So that's some more information over there. Now, GitHub is a place where you can hold code repositories, and it provides Git as a service. You can use Git on GitHub, and it also stores, it's a server for storing all your code. And repositories are the places where the codes are stored with different versions. So it is time for an interactive workshop, but before I go into that, I do want to talk a bit about the resources. Git and GitHub, I'm pretty sure this is a Fireship video. I think it's like a 10 to 12 minute video. It's worth watching if you've never seen Git before. And Superpowers of Git is a documentation that I wrote when I was in my undergrad degree. I wrote this for my project members who knew nothing about Git, even though they were in third year. But it's really good. I think I've tried to make it as concise as possible, and I only talk about the things you will need to know for the project in here, like branching, how to do it, merging, how to do it, cloning, how to do it, creating a branch, etc. And it's a pretty good guide. So that's there if you want to use it too. And yeah, right now we're just going to jump straight into the interactive workshop. Okay, I do want to say we have been sending out invitations to the GitHub repository. So if you're in Penny, you'd have an invite to the Penny team. If you're in Coexist, you would have an invite to the Coexist team. So just check your emails and make sure you accept that. And beginners don't need to worry. Oh, actually, beginners would have received an invitation too for the beginners team. And if you accept that invitation, you should get access to the Software Engineering Practices Demo 2024 Winter Workshop. Okay. So I've got this repository over here for demo purposes. Suppose this is a project that we're working on this winter. You're going to go to this repository page and you'll see the code base. What you're viewing over here is actually the code from the main branch. It's like the master branch. Sometimes it's called main, sometimes it's called master. We're calling it main over here. I've got some readme. This readme instructions is just what you've written in this readme file in the root directory. Now, if I go to issues over here, these are the to-do items that we created. And they're waiting for any of you to pick up for you guys to choose. So I'm just going to show one of them as a demo. Tori, would you be down to do a pull request if I make a change and send it through? Just be ready for it, that's all. So I'm just going to pick some random function. Let's do complete the modulo function. Before we actually start doing this, I should show you how to clone a repository. But if you follow that guide I'd linked, it's also going to be on there. But if you want to clone a repository, it's pretty easy. You just copy the link, either from the URL bar or from here. You just copy that. And make sure you have Git installed on your machine. If you're a Mac, I think you already have it. If not, just download it, search Git on Google. If you're on Linux, fantastic. I think you might already have it too. If you're on Windows, I recommend downloading Git Bash because it provides really nice, it provides a bunch of the Linux tools that you would have had if you used Linux, but since you're not, it will provide some of them, and also it has nice color coding too. But yeah, if you just do git clone and then you type the name of type the URL that you just copied and press enter, it should start cloning the repository onto your machine. The other thing you're going to have to get sorted is authentication. So if you just type git authentication on Google, it's going to tell you how to do it for your specific device. Like this second link, I think. Yeah, there's it tells you just copy that command depending on which OS you're on, and then just do a git push, and it will prompt you to try and log in. But we'll get to that part. So I have cloned the repository over here in VS Code. I hope all of you are using VS Code. You don't have to use VS Code, but we recommend it because we can actually help you if you're using VS Code. If you're using anything else, feel free, but we might not be able to help you because we haven't used the tool. But yep, so we've got this simple code base here. We've got the main.py. You don't need to understand Python even for this. Just need to look at the code. Cool. Now that I have the code, I'm gonna, as a developer, I want to choose something to do, right? So I'm gonna go to the issues page. Okay, let's see. I'm free today, I can do some work, I can contribute to the project. Hey, this modulo function looks kind of cool, it looks interesting. I feel like I can get a lot out of it by, facing the challenge. So I open up the issue and I read the task. Complete the modulo function in order to be able to calculate the remainder after division. Acceptance criteria. When two numbers are passed into the function called modulo, then the operation is mathematically correct. So I'm just going to assign myself to this project. Looks like I am not signed in. I'm just going to go to the other browser. Okay. Now I can assign myself. So I just click on assign myself, assign yourself, and my name appears right over there. Now this is my issue. The first thing you have to do in order to collaborate effectively is you need to make a branch, because you don't want to be committing to the main branch itself. Suppose you make a change that breaks the entire code. Wouldn't it be a shame if your app stopped working while there's 100 people using it? So we're going to create a branch to make these changes so that the main branch doesn't get affected. I'm just going to call it I10 complete modulo function. There's a lot of different conventions different workplaces follow, but typically it uses the ID of the issue you're on. So I'm just going to do git branch I10. Now you can create branches using the command line, or you can create them using the VS Code's inbuilt UI, which is, I guess, easier to use. So I'm just going to use the VS Code UI. I do personally like using command line, and I do recommend you learning it because you'll be much faster using the command line. But you just click on this thing at the bottom corner, which says main, and then you click on create a new branch, okay? And I'm just going to call it I10. Is it? It's 10. Modulo. I10 modulo. There you go. Now I've just created a branch called I10 modulo, and I can click on this to publish the branch, okay? There you go. This branch has been published. So if I go to code over here, I should be able to see it in here, I10 modulo. Woo, we just created our first branch. Let's go. And now we need to, the acceptance criteria is that we need to have a function called modulo, where if you pass two numbers, the modulo is calculated. So let's find that function. We have this here, operation modulo. Just to make sure that we're actually in this branch, I'm just going to type anything in this command line, and it actually says i10 modulo. You can see that, or you can check over here on VS Code, or you can do the command git branch, and you'll see what branch you're in, i10 modulo. So make sure you're not in main. And operations.modulo. So I need to change this function over here. So I just need to do return num1, where is it, mod num2. Okay, there you go, that's done. So that's my change. I'm just going to do a git commit a. That's what I would type if I was using command line, but I'll show you how to do it in the UI. You see this thing over here, source control. If I click on that, it's going to show you which file you've actually changed. So if you click on this, it shows you the exact change you've made. So now remember how we talked about sending your friend the code and they have to figure out what changes you've made. You don't have to worry about that because you've got a nice UI on here. You can see what changes you've made. And if you have the Git extension, I think you can actually see the name of the person and how long ago they made the change as well. So I just click on this plus sign, which stages it for changes. I don't really know what that means. It just means that, hey, I've changed this file and I want to add it to the commit. And to actually commit it, you need to add a message. So I'm just going to write added modulo function. And I'm going to click on commit. Boom, that's gone. And then I can just sync changes, which just does a git push. The git push command is just git push. But it does it for me, and boom, that change has been sent. So now that change is on the i10 branch, not on the main branch. See, it says i10 had recent pushes 8 seconds ago. Now, how do we actually merge this change into main? If I'm working in a team, I shouldn't be the only one responsible for merging this into main, because then I can make mistakes. I might write code that doesn't actually work. So this is why we do a pull request. A pull request gives us the opportunity, it adds another layer into this merging process, which requires someone else to review your code and accept your changes before you can actually merge it. So we're going to create a pull request right now. You can create a new pull request and select the branch, or you can just do this over here, compare and pull request. Added modulo function. You can write whatever here. You can leave this in here, I guess. I'm not sure about that part, but just write some meaningful message. Added a modulo function. You might need more description for some issues, depending on what the issue was. And now you can request a reviewer. I'm guessing Nicholas is probably sleeping, so not him. Okay, Tori. I'm gonna pick Tori. Dota. Bad taste. Okay, there you go. And I just do create pull request. I'm also going to assign myself. So this is fantastic because Tori's going to start getting emails about this. It's going to annoy him so much, even every time I commit changes to this branch now. So it's useful. So Tori is going to be reviewing my pull request now. And suppose I was Tori, I would open up this pull request from the pull request pages. I can see it over here, and reviews, no, I don't know. But I can click on this and I can see the files changed over here. As a reviewer, my job is to make sure the code that they've changed actually makes sense and does what the issue needs it to do. If there's some random bit of code or some bad practice, I can actually leave a comment over here saying that, change this, please. Don't be too harsh to your peers when you review their code. Try and be nice. Cool, Tori, how's the code review going?
Oh, I added a comment.
Added a comment?
In the comment section. No, on the PR.
On the PR.
Don't worry about that.
Okay, fair enough.
Don't worry about that.
Don't worry about that. Okay, cool. Anyways, Tori says it looks amazing, so I'm guessing you weren't able to approve it?
Don't worry about checks.
Yeah, don't worry about checks.
The checks are gonna fail until everything works.
Cool, so Tori's merged it for me. Awesome. So that's pretty much how the process of creating a branch, no, taking on an issue, creating a branch for it, committing a change for it, and merging it back in goes. You merge it by creating a pull request, getting someone to review it. Now, we do have 13 issues, which is not enough for everyone. So if you've used Git before, you probably don't need to do this. If you've used pull requests and stuff before, you can just lay back and help someone else next to you. But if you're new to Git, I highly recommend you to go to this repository, clone this repository on your machine, pick an issue, and make sure you assign yourself to it, okay? The same way I assign myself. And then start doing the issue, and then create a pull request, and make sure you assign me or anyone, me or Tori to it, so we can review your issues, your pull requests. Cool. Good luck. Thank you.